Hello. In this video, we're going to take a look at three examples of using the shell method to find the volume of solids when a region is rotated about an axis. In each of them, I have the graph sketched first, but we will look at what the integral needed will be. So in this first example, we have let R be the region bounded by the graph y equals negative x squared. Really rough picture of what that graph may look like drawn here. It's much smoother than that. And we are between y equals 0, the x-axis, x equals 0, and x equals 1. We're using the shell method to set up but not evaluate the integrals, meaning when we're going around the y-axis with the shell method, we want to slice parallel. So parallel to that y-axis means we're slicing like this, and we're hitting the x-axis, so we know we're going to be in terms of x. So around the y-axis with the shell method means we're in terms of x. So we're trying to find some volume that is the integral from a to b of 2 pi r f of x, or r h dx. Typically r is x, and typically h is f of x, but we need to make sure all of those things are staying what they were. So in terms of x, we're looking between 0 and 1. So our integral is from 0 to 1 of 2 pi. R is the distance from our axis of rotation. So we're going from the axis of the y-axis, meaning our axis hasn't moved at all for us to worry about the radius changing. So if the axis is the x-axis or the y-axis, r stays the same. It'll be that x. And then h is represented by the height of our function. So in this case, from x-axis up to the function is just a distance of the function, which is e to the negative x squared dx. So this integral is 2 pi integral 0 to 1 x e to the negative x squared dx. We're only asked to set up, but this is a really good U substitution example, so I would encourage you to try this on your own to see if you can solve this U substitution problem. So there's the integral we would need. Okay. Taking a look at the next example, we have R being the region bounded by y equals x cubed, x equals 2, and the y-axis. Sorry, not the y-axis, the x-axis. Y equals 0. We want to use the shell method again. So shell implies parallel to our axis of rotation. When we are rotating about the line x equals 2, so we're rotating around this line over here. We're still parallel, so our slices are still hitting the x-axis. Since our slices are hitting the x-axis, we're in terms of x. But our axis has moved. So we're still going to have our volume equal some integral from a to b of 2 pi r h dx. Now, in this case, r is our distance from the axis of rotation. So first, I want to think about our bounds. Our region is from 0 to 2 on our x-axis. 0 to x equals 2, 2 pi. And when I plug in 0, I want the radius to say I am 2 units away from my x-axis. And when I plug in 2, I want to say I am right at my axis of rotation. So since we want to be defining when x equals 0, we want our radius to equal 2. And when x equals 2, our radius equals 0, we really are creating a line. This equation of a line has the equation of 2 minus x. Of when I plug in 0, I get a radius of 2. And when I plug in 2, I get a radius of 0. So our axis, our radius is 2 minus x. And then our height is still just our function unchanged. It's in terms of x, so our function is x cubed dx. And that integral would find our volume of rotation for this problem. Let's take a look at one more example. Let R be the region bounded by y equals x cubed, x equals 2, y equals 0, and rotating around the line y equals -1. So we're going around this horizontal line, and we're using the shell method, so we're slicing parallel to the axis. So slicing parallel to the axis of rotation means we're going this way. If I continued these slices out, I'd be hitting the y-axis. So hitting the y-axis tells us we are wanting in terms of y. So our integral is going to be some volume that is a to b 2 pi. We need to figure out a radius and a height in terms of y. So first things first, figuring out the bounds a to b. When we're in terms of y, it's where is the region? When we're in terms of x, where is the region in terms of x? But where is the region in terms of y? It is going from the x-axis, y equals 0, up to this point where x equals 2. And if x equals 2, we know by this equation y equals x cubed, y equals 8. So we're going between 0 to 8. So our bounds are 0 and 8, 2 pi. And now the radius. When I plug in that lower bound of 0, we want our radius to be 1 because we're trying to get from -1 up to the x-axis. So when y equals 0, we want r to equal 1. And when y equals 8, we want r to equal 9 because -1 up to 8 would be a distance of 9. Well, that is a pretty easy equation to see. This means our radius equals y plus 1. That is the radius for our integral. And then height, we are in terms of y. So now when we're looking off of this y-axis, we are to see what the reflection of, well, since we're off of this y-axis, when we're finding a height, it's based off of how far are we in terms of y. Well, this height here is this farthest line x equals 2 minus this curve, which is defined by y equals x cubed. but we want things in terms of y. So y equals x cubed is the same as x equals y to the 1/3. But finding the height of these functions is that farthest distance. That is x equals 2 minus the closer distance, the closer function, y to the 1/3. This integral will find the area or the volume created when this region is rotated around the line y equals -1.